Hello there. So today is going to be a math class. We will be specifically talking about index numbers in statistics. So an index number is a way of expressing economical data and comparing or contrasting information. It has two parts to itself, a price value and a base value. So the index numbers we will be talking about in this video are simple, aggregate index, Laplace's index, and Fisher's ideal formula. So first we will be talking about simple aggregate index. It is used to measure the difference in sums of at 2 points in time. The simple index is a way of combining a two group of items to form one index. The simple index is the sum of the current price quantity divided by the base value. So the E looking symbol down below represents the sum. So this is an example of simple aggregate index. For example, these are some car prices provided. Suppose the trucks and the coupes and the sedans, SUVs, and prices of last year, prices of current year. To solve for simple aggregate index, there is a formula. So the E looking symbol, as I mentioned earlier, represents the sum. PT means the current and the PO means base, multiplied by 100. So we add up all the values and then we multiply it by 100 and we get the answer, which is 11.6.2. So what is Laplace's index? It is used to measure inflation. As being a weighted index, it captures changes in the price better than any other index number. So for example, we need to find prices of such products as mentioned down below. So now how would we use Laplace's index? We look at the quantity of the product and multiply them with the prices that are provided. Not just the prices, but quantity into price of last year, quantity into price of current year, and suppose we have the certain amounts and prices of last year, prices of current year, as you can see. So Laplace's index, multiply the quantity with prices of last year, we get and add them up as mentioned, and then we just do as it says on the screen and we get the number, which is 155.7 is the index. So the reason why the Fisher's index is actually an ideal formula because it is a geometric mean of the two either other formulas, which is Laplace's formula and the Pasch formula. So the formulas are given below. The Laplace's is already done and the Pasch formula is given below, and for the Fisher's we just multiply the two in the end. So for an example, so we have a commodity, here's the commodity, and the price and the quantity and all the labels are given. We have given numbers. So first we have to label all the commodities. There's PO and there's QO, there's PN and QN. So in order to get the answers for these, we have to multiply them accordingly as shown in the other side of the table. And then how to find the F, as mentioned before, you just multiply it and then take the square root of it, and the final answer would be $149.40. And in conclusion, so I would also like to mention the QN and the PO, they actually represent the past and the present value, as you can see that by the 2000 and the 2004 and 2008 years. So in conclusion, I would say that index numbers are a way of expressing economical data and comparing or contrasting information, and also that the index number has two parts to itself, which is price, quantity, a value, and base value. So what we learned today is simple aggregate index is a way of combining a group of items to form one index, and Laplace's index is used to measure inflation, and Fisher's ideal formula is called ideal because of the geometric mean of the two other formulas and the Pasch index itself. And by multiplying the two indexes, we actually get the Fisher's ideal index answer. And here are the citations. Thank you.